Hello guys, welcome back to my channel Mason African Motives. In this platform we shall be working on mathematics N3, that is working with the geometry. So we are actually given the question from one of the question papers that we shall be working on. So if you're new to my channel, you can consider subscribing so that you won't miss any of the classes that we shall be having for mathematics N3. So that's the question paper that we have here. These are the questions that we have, and it's a total of 20 marks. Okay, so let's see what we are given. Consider the following fig A. EF is parallel, so we are given in this case from this information that EF is parallel to AC. So this is E to F and A to C. These two lines, they are parallel, and you are given BD is perpendicular to AC. BD and AC, they are perpendicular, that this is at 90 degrees like that. Okay, so and we are given also AE is equal to EB from A to E, that is this distance from A to E and from E to B. Okay, so let's see, which means E is going to be the midpoint. This one is going to be the midpoint if we have equal lines like that, that E is going to be the midpoint. Okay, so the first question is to determine the following, the gradient of AC. Okay, so we have the gradient of AC, so take note we have the point A and the point C. So the gradient of the line, we simply use this formula for gradient. Okay, so this is 4.1. so remember this is the gradient for AC, and gradient is the change in y over change in x. So it's going to be y2 minus y1 over x2 minus x1. So this is from point 1, point 2. So anything that has 2 is going to be taken from C. So our C in this case is minus 7 in terms of y. Remember this is xy, so it's minus 7 minus 5. So this is y2 minus y1. So it's minus 7 minus 5 like this over x2 minus x1 from C to A. So x at C is 3, so it's 3 minus x there at A, which is 6, so it's 3 minus 6. Okay, so from this formula that we had, if we are to simplify, minus 7 minus 5, so this is just a fraction like this, which is minus 7 minus 5 over, that is 3 minus 6. Okay, we have 3 minus 6 there, 3 minus 6, which is going to give us something like 4. So this is 4. So that means the gradient of line AC in this case is equivalent to 4. Okay. So this is actually 4. Then we have the equation of AC in the form of y is equal to mx plus c. Okay, so according to our syllabus, in fact, according to our syllabus, when you want to find the equation, you're going to use this formula, y minus y1 is equal to, they want you to use formula, I don't know why, but actually this is what they require you to use. There are so many ways actually that you can use to find the equation, but this is the basic formula that they need you to use, where this y1 and x1 represents any point on AC. So we have point A, we have point C. You choose any part that you're going to take the value of y and the value of x. Okay, and this m is the gradient, so it's going to be y minus, so in this case I'm going to choose point A where I have 6 and 5. So y1, this is the value of y here, which is 5, so it's y minus 5, which is equal to m. That is the gradient that we obtained. Remember, we obtained the gradient of AC to be equal to 4, so it's going to be 4 into x minus x1. So x1, you substitute the value of x on the point that you have taken. So the value of x here is 6. So that is what you're going to have. Okay, so let's expand this bracket and see what you're going to have. We have y minus 5, which is equivalent to multiply. This is same as 1x, so it's 4 times 1x, which is 4x. 4 times minus 6 from your calculator, this is negative 24. Okay, then transpose, since we want this format of y is equal to mx plus c, take note we are given a format which is the gradient intercept format. So we are going to transpose this negative 5, which is going to be positive 5 on that end. So y is equal to 4x minus 24. We are going to add 5 to minus 24. Okay, let's see what you're going to have. Negative 24 plus 5, which is going to give us something like negative 19. Okay, so we are going to obtain negative 19 in this case. So this is the equation of line AC. This is the equation of line AC. Let's just have this. We don't know, maybe we might need this equation later on, so let's just write it and leave it. Okay, we move on to the length of EC. Okay, so this is the length of EC. Okay, so this also is given on your formula sheet. This length is actually given with the distance formula. So this is 4.3. So this length is taken from what? From the distance formula. So which means EC, which is the length of EC, the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. This is the distance formula. So you're actually substituting, this is the length of EC, which means your E is 1, your C is 2. So it's x on C, which is our x here on C is 3. So it's 3 minus x on A, which is 6. So it's 3 minus 6. That is 3 minus 6 in this case squared. So no matter the way that you're going to take this, even if you write as 6 minus 3, you're going to obtain the same answer, okay? Then y2 minus y1, this is minus 7 minus 5, okay? So we have plus minus 7 minus 5 like this squared. Okay, so this actually you can use your calculator to simplify this value. So it's the square root of, just use it like this, square root of, put a bracket. So the first value was 3 minus 6 squared. Okay, so this is 3 minus 6, you close that bracket, squared, plus we move on to the y there, which was minus 7 minus 5 if I'm not mistaken. That is minus 7 minus 5, you close that bracket and square it. You're going to obtain 3 square root of 17, which is as a decimal, is 12 comma something. So you can express it as a decimal, which is 12,369 units. So this is length. You can have this like this, or you can just have it as what? 3 root 17. So it can be written as 3 square root of 17 units. So distance is measured in units. We do not know these units. Are they meters? Are they centimeters? So that's why we just write them as units like that. 3 square root of 7 of 12 comma the square 12,369 if you round off to 3 decimal places. So that's what we had. Okay, let's move on to EF. Okay, calculate the equation of EF on 4.4. We need the equation of EF. Okay, this is our EF here, the point. We have point E from line F here. So as you can see on this one, we are just given a point. This is 4.4. We are just given the point E, which is 1, 2. This is what we just have on this one. But they need us to calculate the equation. So how are you going to do this? We know that these two lines, they are parallel. And for two lines to be parallel, it means the gradients are equal. So which means the gradient of this line EF that we want to calculate its equation, the gradient of EF is equivalent to the gradient of the line that it is parallel to, which is CD. So these two, they have same gradient because they are parallel. Take note on this one. So it means we have the gradient of EF. Why? Because the gradient of CD is there. We calculated this from this CD. This is the same as this AC as it is. Actually, this is the same as AC. This is one and the same thing. Okay, so we calculated this gradient of AC, which is 4, which is the same as the gradient. Remember, this is on a straight line. So the gradient from C to D is the same, from D to A is the same as AC, because they are collinear points. Okay, so we have a gradient of 4. So we have a gradient and we have a point. So we know from the previous format that I showed you that it was y minus y1. This is actually a formula that is on your formula sheet. That's how they write this in your formula sheet. So which means they need you to use this one, because that's what they have given you in your formula sheet, where you have x and y here. So this is x1, y1. So it's going to be y minus y1, which is 2, which is equal to m, that is the gradient of 4, into x minus x1. The value of x1 is 1, like this. Okay, so let's expand bracket just like the previous part so that we can collect the terms to the other side of the equation. So it's 4 times x, that's 4x. 4 times negative 1, which is negative 4. So y is equal to 4x transpose this negative 2 is going to add. So from your calculator, minus 4 plus 2, you are going to obtain minus 2, like that. Okay, so that is going to be the equation of the line EF. So that is what we are having for this line EF as the equation. Okay, so let's see the other question that we are given. So that's how they ask these questions. Then calculate the coordinates of what? Of B. Calculate the coordinates of B on 4.5 here. We need the coordinates of B. Okay, so this is the point B here. Take note from what I explained before. Remember, I told you that this E is the midpoint. So if E is the midpoint, which means there is a relationship between these 3 points, the midpoint of A and B is going to give us what? Is going to give us this point E. And we know that the midpoint is obtained by this formula, x1 or it's x2, whatever way that you're going to use, like this. This is how you're going to obtain what? The midpoint of a certain point, which means when we add here, let's just say this is our point B, this is x and this is y, like this. So it means when you add this x to the corresponding value of x here, which is 6, you're going to formulate an equation, x plus 6 over 2, like this. You move on to this part of y. So it's going to be y plus this y here, which is 5. So it's y plus 5, like this, over 2. So this point is the midpoint. This is your midpoint here in terms of x and y. But this midpoint in terms of x and y is equal to the midpoint that we are given, because the midpoint is already there, which is what? Which is this E, which is 1, 2. So you're going to equate to the midpoint that you are given, which is 1, 2. So why equating this? Why are we writing like this? We have actually formulated an equation here. How? These are equal points in terms of x. So we're going to equate this, because this is x and this is y. The same, this is x and this is y. So you're going to equate this to 1. X plus 6 over 2, you equate to 1. We do the same for y here. Y plus 5 over 2, you equate to the value of y here, which is 2. So which means you can solve this equation, because this one is same as over 1. So cross multiply. 1 times x plus 6 is x plus 6, which is equal to 2 times 1, which is 2. So x is equal to 2 to that side. 6 to that side is going to be minus 6, which is negative 4. You do the same. This is over 1. You cross multiply. Y plus 5 is equal to 2 and 2, which is going to be 4 from your calculator. So y is equal to 4 minus 5, which is going to be negative 1. Okay, so remember this x and y, we have taken these points from what? From B. So x represents the value of x at point B, y represents the value of y at point B. So therefore the point B is going to be equal to value of x, which is negative 4, and the value of y, which is negative 1. So this is going to be the point B. So that is what we had in this case on 4.5. We're actually given the midpoint. So you are going to use the midpoint concept. So in this case, we used the midpoint concept. When you are given a midpoint, you can find the midpoint in terms of x and y. Then you equate that midpoint to the one that you are given from your diagram, which is 1, 2. Okay, so we have the point B, which is negative 4, negative 1. That's negative 4, negative 1. Maybe we might use this point later on, so let's just indicate it. Then we have 4.6, the equation of BD, okay, again in the same format, y is equal to mx plus c. Okay, where is BD? This is the line BD. So as you can see, we are now forced to use this point because we do not have this point D. We only have point B. On this line BD, we only have the point B. So are you seeing that if you made this an error, it's going to affect another question again? Okay, so on 4.6, we only have the point B there, which is -4, -1. Okay, remember we need to find the equation, but we are only having the gradient. We are only having the point. Where are we going to have the gradient? If you are to cross-check BD here, we are being given before that BD is perpendicular to AC. And we know that for perpendicular, the product of the gradients, which is the one that is perpendicular BD, multiplied by the gradient of the other line that is it is perpendicular to, which is AC, is going to give us -1. So if two lines are perpendicular, the product of their gradients is going to give you -1. So we have the gradient here of AC. We calculated this before. So it's the gradient of BD, the one that we want to calculate, multiplied by the gradient of AC, which is 4, the one that we calculated. We must obtain -1. So you divide by 4, which means the gradient of BD in this case is -1/4. So we have the gradient and we have a point where we have x1 and y1 like this. So we are now back to that formula because the gradient is there. So remember the formula is y minus y1, which is equal to m into x minus x1. So that's y minus y1, which is -1. So it's going to be a +1, which is equal to m, that's the gradient, which is -1/4, into x minus x1. So it's going to be x1, which is -4. So negative and negative, that's a plus. Okay. At this stage, we are going to have y plus 1, which is equivalent. Let's multiply. That's -1/4 times x, which is just -1/4x. Then it's -1/4 times 4. From your calculator, you must obtain -1. Let's just do this together. -1/4 multiply by 4. So if you multiply this by 4, you're going to obtain -1. That is what you're going to obtain, -1. Okay, that's what we have in this case. Okay, so transpose this because we need the format of y is equal to mx plus c. So you're going to transpose this 1 to this side. Is going to be -1. So you have -1/4x. -1 from your calculator is going to be -2. Okay, so that's what we had on 4.6. This is actually 4.6 when you are calculating the equation of the line BD. So as you can see, it was worth it because it's 3 marks for this one. And the last question with 4 marks is the coordinates of the point D. Okay, how can we calculate the coordinates of this point D here? Okay, I just want you to see something here. I just want you to see something. That is 4 marks there. The point D there, we cannot like find these coordinates direct, but I want you to see that the line BD, if you continue this line like this, and with AC, these two lines, they intersect at a point at point D. So D is the point of intersection. So remember what we have at the point of intersection. That's at the point of intersection, the two equations are equal. So at the point of intersection, the two equations are equal. This is what you need to know. At the point of intersection, the two equations are equal, or the two graphs are equal in actual sense. The two graphs are equal. So if the two graphs are equal in this case, we mean to say this graph of AC, this line AC, which we found its equation on 4.2 because the line AC is there. On 4.2 there we calculated this. So let's cross-check what we had on 4.2. This was the equation of line AC, which is y is equal to 4x minus 19. So we have y is equal to 4x minus 19, which is equal to the equation of what? Of BD. Okay, we calculated BD, that is on 4.6. okay, so 4.6, this was our 4.6 here, so this was our BD. So this is the equation of BD, which we obtained y is equal to minus 1 over 4 x minus 2. Okay, so we have y which is equal to minus 1 over 4 x minus 2, like this. So I'm saying that to find the point of intersection, these are the two lines that we have, the line AC and the line BD. These are the ones which are intersecting at what? At point D. So you solve these equations because at the point of intersection, these two are equal. So it means this is y, this is y. So these two are equal. 4x minus 19 is equal to this part with x here, which is minus 1 over 4x minus 2. So which means you have formulated an equation where you can solve what? Where you can solve for x. So transpose negative 4 to this side is going to be positive. It's negative 1 over 4. It's going to be positive 1 over 4. So it's 4 plus 1 over 4 because it's going to be a plus that one. So 4 plus 1 over 4 like this is going to give us something like 17 over 4. Is that so? Yes, 17 over 4. So we are going to obtain 17 over 4x, which is equivalent to negative 19 to this side is going to add. So it's going to be positive 19. So it's negative 2 plus 19. Okay, negative 2 plus 19. That's plus 19 like this, which is going to give us 17. Okay, so this is going to be 17 like this. So to find x, guys, you can actually divide by 17 in this case, by 17 over 4. So this is the 17 that you have, then you divide by 17 over 4 like this. So the calculator can simplify this for you. So you're going to obtain 4. So x is equivalent to 4 at this point. So to find the value of y, what you're going to do is to substitute into any one of these two equations. Remember, we said at the point of intersection, these two equations, they are equal. So you're going to substitute into any one of these two. So I'm going to choose the first one. So it's going to be 4 into x, which is 4 minus 19 like this. So it's 4 by 4 minus 19. Okay, that's, you can just put this in bracket. That's 4 by 4 minus 19, which is going to give you something like a negative 3. So that is the value of y at this point. So remember, what we are solving is the value of x and the value of y for the point D. So therefore, the point D that you're talking about, remember, a point is made up of x and y like this. So the value of x is 4 and the value of y is minus 3 at this point D that we are talking about. So that's how they ask these questions. That's how they ask these questions. To find a point when it is at the intersection of two lines, at the point of intersection of two straight lines, what are you simply doing? You are solving the equations. Why? Because at the point of intersection, take note, at the point of intersection, the two graphs are equal, which means the two equations are equal because these graphs, they are represented in form of an equation. So you are simply solving the given equations simultaneously. So like I said, if you could have substituted, you could have find the same answer when x is equal to 4. This was minus 1 over 4 like this, minus 1 over 4 times 4, then whatever you get minus 2. So you're going to obtain minus 3, which is the same answer as this one because they are equal at that point. So that's how you're going to determine the coordinates of the point D. So that's what we had for this question, as you can see, summing up to 20 marks. So guys, these marks, they are very many. So we have a lot of marks there. So not to miss these marks, guys, make sure that we revise on more questions from past exam papers and so on, so that we equip ourselves for the exams which are ahead of time. So that's it, guys, from Mezon African Motives. Till we meet again.